Firstly, determine the total electrical load. The first step is to determine the total electrical load that will be served by the MSB. This can be done by adding up the electrical loads of all the equipment, appliances, and devices that will be connected to the MSB. For example, let's assume that the total electrical load of a small commercial building is 100 kilowatts, which includes lighting, heating and cooling, computers, and other equipment. Secondly, determine the type of distribution system. The next step is to determine the type of distribution system that will be used. This can be either a single-phase or a three-phase system, depending on the specific requirements of the electrical system. For this example, we will assume that a three-phase distribution system is required to meet the power needs of the building. Thirdly, calculate the total power. Once the total electrical load and distribution system have been determined, the total power can be calculated using the formula power in watts equals voltage in volts x current in amperes. For a three-phase system, the total power can be calculated using the formula power in watts equals square root 3x voltage in volts x current in amperes x power factor. The power factor is a measure of how efficiently the electrical power is being used and can be obtained from equipment specifications or measurements. For this example, let's assume that the power factor is 0.9 and the voltage is 240 volts. Using these values, the total power can be calculated as follows. Total power equals square root 3 by 240 Vx, 100, 000W, 240 V by 0.9, equals 192,450.09 watts. Fourth, select the MSB rating. Based on the total power calculated, the appropriate rating for the MSB can be selected. MSB ratings typically range from 100A to several thousand amps, depending on the size of the electrical system. The selected MSB rating should be higher than the total power calculated in Step 3, to ensure that the MSB can handle peak loads and future expansion. For this example, we will select an MSB rating of 500A. Fifth, ensure compliance with regulations. It is important to ensure that the selected MSB rating complies with local electrical codes and regulations, which may specify minimum ratings for MSBs based on the size and type of the electrical system. Electrical codes and regulations may also specify requirements for the installation, maintenance, and testing of MSBs to ensure their safe and reliable operation. The three-phase power enters the MSB through the incoming lines and is distributed to the various circuits through the outgoing lines. The incoming power is first routed through a main circuit breaker, which can be opened or closed to control the flow of power. The main circuit breaker is typically rated to handle the maximum power that the MSB is designed to handle. The outgoing circuits are protected by individual circuit breakers or fuses, which are rated to protect the specific loads they are serving. The outgoing circuits can be configured in a variety of ways, including branch circuits, feeder circuits, and sub-circuits, depending on the specific requirements of the electrical system. In summary, while the calculation of an MSB may include the lighting and power circuits, the selection of MCCBs and RCCBs should be based on the specific requirements of the electrical system, including the total electrical load and distribution system, rather than just the lighting and power circuits.